Welcome back to Civil Engineers YouTube channel. In this practical video, I will show you steel reinforcement details in which we have more than 5 big mistakes in the construction of this plinth beam. So let's get started, guys. If you have any question related to this short video, so you can comment, I will try to reply your answer. Guys, you can see clearly, this is plinth beam which depth is 15 inches, width is 12 inches. On the top of this plinth beam, they placed the steel reinforcement for plinth beam construction. You can see we have 2 steel rods at the bottom and 3 at the top. So this is one of the big mistake. That's why, because in this plinth beam, we are providing more numbers of steel rods at bottom portion because this is tension zone and concrete is weak in tension. So therefore we are placing maximum numbers compared to its upper portion are in compression zone. Second, guys, you can see we have 3 steel rods in upper portion are in compression zone where we required minimum numbers of steel rods compared to its bottom. So this is one of the big mistake. The second big mistake, guys, you can see this is the end of the beam, but they didn't provide any development length, which is very important to make a good bond between steel and concrete, but unfortunately they didn't place the development length. Guys, you can see clearly they cut the steel rods with the level of RCC column. The third mistake, guys, you can see the spacing of stirrups with hooks. Guys, you can see we have 2 steel rods, dia is 12 millimeter and 3 bars in upper portion where we have 3 bars, dia is 12 millimeter. Next, guys, you can see the spacing of the stirrups, which is maximum here, but this is not the proper steel reinforcement for this plinth beam. That's why, because the spacing is here at the distance of L/4 about 8 to 9 inches and the hooks are bent on 90 degree, but it should be provided on 135 degree. When we placed the hooks or bent the hooks on 135 degree, so it's resist with earthquake, but this angle which is 90 degree in these stirrups, so it can't work properly against the earthquake. Next, guys, you can see the spacing is here about 12 inches. So this is not the proper steel reinforcement design in the construction of this plinth beam. Next, guys, you can see this is end of this beam, but they didn't provide any development length, as I told you before. On the other side, if you see the laping length, which is not sufficient, which is about here 12 inches, but it should not be less than 50 to 60 D, where D is die of steel rod. For this 12 millimeter die of steel rod, we required minimum 24 inches laping length. Guys, you can see here, this is about 9 to 10 inches. But at the distance of L/4, where we have negative bending moment, we should place the stirrups closely. Next, guys, you can see in upper portion of laping, they provided laping at the middle, but these are 3 rods about. Guys, you can see that is the other beam. In bottom we have 2 steel rods, in upper portion we have 3 steel rods, but they didn't provide at the end of the beam development length, which is very important. Guys, you can see clearly. This is one of the mega projects. So for that reason, they should use the structural drawing. According to structural drawing, they should place the steel reinforcement for plinth beam, for column, and also they should provide those technical terms which are very important and helpful for construction site. But they didn't follow any technical term in this steel reinforcement details. Here, guys, you can see everything is wrong, but if you see the length or the span between 2 columns is here about 18 feet. I don't know which grade of concrete they will use for this construction. I'm wondering when I'm guiding you for this steel reinforcement because everything is wrong in this construction. They used about 6 mm die of steel rod for stirrups and 12 mm for plinth beam. Hope this short video can help you. Thanks for watching. See you in next video. Goodbye.